This question came for 1 mark in EC GATE 2016. The diodes D1 and D2 in the figure are ideal and the capacitors are identical. So the circuit is shown here. The product RC is very large compared to the time period of the AC voltage, which means we can neglect the discharge or droop in the voltage. Assuming that the diodes do not break down in the reverse bias, the output voltage V0 in volts at the steady state is. So now let's look at the circuit. The input voltage is plus 10 volts minus 10 volts here. So when it is in the positive half cycle, when this side is positive, this side is negative, obviously diode D1 will be forward biased as well as D2 also will be forward biased. Hence the capacitors would get charged. When they get charged, they'll get charged this way. They get charged to Vm, and this side they get charged to Vm. Now once the voltage reaches Vm, obviously the capacitors get charged to that value, and afterwards when the input voltage decreases, the diodes will have a negative voltage across them, which means the diodes would be reverse biased. Hence the conduction of the diodes is present only for the quarter of the cycle, and afterwards the voltage across the capacitors would remain same. But of course we can think of the discharge of the capacitor through the resistor, but they have given already that the RC value is very large compared to the time period. So hence we can neglect the droop that will happen because of the discharge. Hence we can fairly assume that the voltage across the capacitors will remain Vm. In that case, the voltage at the output will be, with respect to reference, plus on this side, minus on this side. This is plus Vm plus this is minus Vm. Hence we have V0 is equal to Vm minus Vm, which will be 0 volts. So in steady state, the output voltage will be 0.